What? I just hold the screen right. Alright, homework today, 45 to 50. If you're sick, stay home. Sorry, to our classmates who are sick. Love you, miss you, but stay home.
No, we can stay away.
Well, you guys don't want to be sick, right?
Yeah, I don't think
Also, you might want to think about, I think I just upset Ian, but you might want to think about the fact that we have so many sick friends, like maybe not high five, maybe not hug, maybe not like physical contact like you would normally do since it's February and it's the middle of illness season. So yeah, if you like try to high five me, I'm probably going to say no. Actually, I'm going to say no. If you try to pound the rock, maybe pound the rock, because this is normally cleaner than this. This touches everything.
Can we just like
I mean, sure. We can always air high five.
that's how you don't.
Alright, so we today are talking about fraction and decimal coefficients. More specifically, equations that involve them. But yesterday you guys talked about some multiplication, or not yesterday, Tuesday more so. And the sub left me a note saying that there was a little bit of confusion with percentages being able to be looked at as scale factors. So I just wanted to review a scale factor is how we go from one. So really, what like to give you the what we're going for here. CPM is trying to constantly connect algebra, geometry. Right? Algebra is more like the writing, the doing, the mathy side of it. Geometry is like how it looks, right? The shapes and things like that. A scale factor on the geometry side makes things bigger or makes things smaller. So shrinks or enlarges, scale factor. A percentage on the algebraic side looks at if I have less than 100% of something, I have less than the whole. If I have over 100% of something, I have more than the whole. I get bigger. So they're essentially the same thing. So we start to talk about them kind of interchangeably. So you don't have to like have that dead down all the way right now. I just wanted to bring it back up. Scale factors and percentages can kind of be used interchangeably. So when we talk about our exponents, or sorry, not our exponents, our variables, I think most of us are pretty comfortable with being able to look at them as physical objects, right? Again, algebra to geometry. The algebra, we call something x because we don't know it. The geometry, we can look at something that we don't know. Remember, this tile could be really big or really small. X squared just means it's x by x. Ends up with a square tile. Still, I don't know what x is. Could be really big, could be really small. You cool with all that? Just double check. Then we can have coefficients. Now, a coefficient tells you how many of something we have. Like if I have 3 x tiles, 2 1 tiles, another x tile, etc. I don't feel like I need to go through all of those. So what we're going to do today is talk about, well, what does it mean when I have like 5x versus 2/3 x squared? What does that actually mean for us? How can we represent this? Are the representations different? And what's the best way? We always want the best and the easiest way. So we'll get there. So anyone want to read 39? Or you guys just want to keep this? Nah, go ahead. Thank you very much.
The Sutton family.
Sutton.
Sutton. The Sutton family took a trip to the mountains in the Rocky Mountain National Park. Linda and her brother Lee kept asking, "Are we there yet?" At one point, her mother answered, "No, but what I can tell you is that we have driven 100 miles and we are about 2/5 of the way there."
Sure.
Linda turned to Lee. "How long is a trip anyway?" They each started thinking about whether they could determine the length of the trip from the information they were given.
So this is going to make you guys think I'm old, which I'm starting to feel like I'm old.
No,
You're old.
You're
Okay, I will tell you, I'm starting to like pull out gray hairs. Y'all are giving me gray hairs right along here. I'm trying to fight it. But so, back in the day, I heard somebody mumble like, "How would you even know that? 100 miles, 2/5." My mom, on our trips that we used to take as a family, would have the atlas out. If you don't know what the atlas is, it's a giant book of maps. And she would have our route mapped out, like literally with a highlighter. She'd draw on the maps. And she would be able to tell us about a fraction of like, okay, well the route's this long, we're about halfway there. We're about so if you have a decent understanding of fractions, being able to say we're about 2/5 of the way down the route isn't hard to know. And on the car, you have an odometer that keeps track of how far you've driven. You normally reset that at the beginning of a trip. Making a statement like that is not that outlandish. We've driven 100 miles. The person driving can tell you that immediately. The person with the map could say, oh yeah, we know what exit we're at. All the exits are numbered. They're numbered on the map. They could say, oh, we've gone about 2/5 of the way. How do we use that to approach figuring out the whole distance traveled? How do we use that information? They've already got a model set up for us. Nine? So I can break it down to the unit rate. So I kind of scale it down first. Right? Scale it down. So I have 2/5. You said we want to break it down to the unit. Unit rate is kind of being used loosely here. But we're breaking it down to what? Being how many miles? Yes, we break it down to 1/5 being 50. Draw a quick model of this on your paper, please, just to remind yourself of what we're doing. Just a quick one. You don't have to label it Linda's method. Just make sure you have 100 compared to 2/5. Give the 100 a label so you know we're talking miles. We can break this down and say, well, 1/5 is 50. Then, so we scaled down, right? 50, that was half of what we had been given. How do we get to the whole trip? Well, scale it up. Quintuple, fun word to say, quintuple the value that we have. We do the same thing in geometry. If given a shape, and you know the shape you have is 2/5 of a larger shape, you can do the same thing. Except there's a really easy way to do both of those steps that we just took at the same time. How many halves does it take to make a whole? 2. You guys think you're so funny. How many thirds does it take to make a whole?
3.
What?
How many fourths?
3.
5.
Stop.
I think half is 18.
How many 2/5 does it take to make a whole?
5 over
5 halves. Think about what we did. Hold up, up here. Think about what we did. We divided by 2 and then multiplied by 5. This does that immediately. Multiply by 5 and divide by 2 at the same time. To use scale factors, or kind of like undo them, we're going to start multiplying by the fraction that's flipped over. What do we call that?
Reciprocal.
Reciprocals. About what? So, all I was trying to say is this, to get 100 up to the bigger shape, immediately, if we know that we were multiplying by 2/5 on the way here, we've talked like if we were multiplying by 5, divide by 5, right? That's easy. But dividing by a fraction is actually multiplication by its reciprocal. So if we multiply by 5 halves, I will get 250, which would be the value of x. Ava.
What is the triangle? Like, there's a big triangle and a small triangle.
So this is showing the geometric versus the algebraic. So geometric would be like changing size of a physical object. Algebraic is just changing numbers based off quantity. Right, so the geometric shows you how something would scale, literally get bigger or smaller. So this triangle is 2/5. It's a shrunken version of that triangle. So this triangle is actually 5 halves, or really we could say times 2.5, because times 5 halves is times 2.5. So it's double and another half. Let's move on. So we already did this too. This is why we're in accelerated 7. And we already did this. Does everything we just covered make sense? I'm gonna move kind of fast today, but that's like, kind of anticipated that. So we're gonna start multiplying by reciprocals. So this, if you want proof of y, the algebraic evidence, actually I would write this out if I was you, is we know 2/5 of a quantity equals a value. This is good algebraic practice. Please write that out. If you can change your font or color or make yourself a mental note. In an algebraic equation, we can always destroy a coefficient. Destroy meaning like take it to 1, make it disappear, by multiplying by its reciprocal. So regardless of dealing with anything else we're doing with an algebraic expression or an equation, we have to do the same thing on both sides. That will lead me to my final answer. Actually, 200 miles in this case. And there's that shot. Alright, try these. You got this. You in the car.
It's a microphone. Don't question it.
You could have used it. I'm going to use random cards to help me solve these.
What's 27 almost 35 out of 2? 9? I asked that question. I used to ever since you start doing that. Okay. Don't you touch my legs.
I'm not weird.
You can't just say I'm not weird.
You gotta prove it.
Yeah, Annie.
No, you're supposed to have a textbook out. It's so hard to have a textbook out in class every day.
Yeah. Especially when you don't really use it.
That doesn't make me a very good argument.
Yeah, I know.
It takes up more justice. Yeah.
Yes.
Right.
Good
You
job.
can have
42.
Because you
He doesn't have a logo. You're making us do so much.
Oh my god, that's like.
Start crying, everybody.
I can cry for you.
Stop crying.
So, 80.
Wait.
Yes.
It's negative.
Zach, what do I multiply by an A on both sides? 2/9. Hey guys, here's how you make your life easy. Cross reduce when possible. I saw people reaching for calculators. Cross reducing, reminder, not cross multiplication. Cross reducing. Yeah. Yeah, but we don't need to. Sure, it's fine that you should be able to do that, but 27 and 9 can both reduce by a factor of 9. This can become 1 and that can become 3 and make my life a whole lot easier. X should be 6. Make your life easier. Try not to reach for those calculators.
Yeah, lol.
Okay.
I was just gonna do it the hard way.
Yeah, until they rise up and take over. Izzy, what do we multiply 2 sevenths by to turn it into a whole? 7 twos by. No, we can't say that. 7 halves.
7 twos.
Hey, give me your eyes, because I think a lot of us didn't do this. 12 and 2 could both divide by 2, making this 6 and 1. Now I don't have a denominator over here, and I get 42. And that's it. We're done. Oh my gosh, but this we did without a calculator.
Love what you do that. Magic.
And hold on. For all the marbles.
Magic.
Tyler, what do we multiply by here?
We multiply by negative 4/3
Why?
because, well, the reciprocal, would have to be, wait. Yeah, the reciprocal would be switching the 4 and the 3 but keeping, the negative because, I don't think it matters whether we divide by negative.
No, it
I was about to then ask a follow-up of, does it matter why I put my negative on the 4 now instead of the 3?
No.
Does the location of the negative matter?
No.
Whether it's in the top or bottom or out front. I just don't like it out front because then it can look like with the fraction bar.
Yeah.
It's a me thing, right? It's just,
I put it out.
it's not you, it's me. So I put it in a part of it.
I put it out front. That's why I was kind of like.
21 and 3 can both reduce by 3. This becomes 7.
Reflex now.
Or 28.
Oh, yes, negative 28.
Negative. Check that your answer is negative.
It's correct, Monday.
All right. Now we're diving into 4-1 or 7-5. 7-1-5.
What?
Calm down. Depending on how fast we move is going to determine what tomorrow's plan is. Wow, you guys are really reactive. No. Okay, so they pay me a meager sum to make decisions and determine where we're going. These 3 lessons are meant to be merged in 2 days. I knew looking at 714 that you guys are better than spending much time on that. So we're going to look at some of this lesson. We may or may not use the resource page because we might just blast through this one really fast. And depending, we might even start 716 today. We'll have homework time tomorrow. So that you can go into the weekend with a bit of time to work on stuff.
Wait, I have a question about
Yes.
that. So should we not do our homework and
No, you can do it. And actually, we still might have time for homework. All right. So there is a resource page that accompanies this, but I have a feeling that we don't need it. Look at this situation for a moment. Figure out if you can represent it mathematically and determine how to answer the question. So just take a moment. You don't need to talk to read. Anybody have some advice for us? Nine? Man, ooh, okay, so we could make a number line, right? And show that 4/7 of it got, well, that'd be 9, and then 100% of it would be unknown. Right, so if I draw it out like that, 4/7 is slightly over half. So that was 9 apartments, right? And this was 4/7. Okay. You don't have to follow me right now. I'm just 9. Scale it down. Okay, so if I want 1/7, I would have to divide by 4, but I don't really have to do that because we know that that'll get us 1/7. Well, that's not nice. So we could honestly just say it's like 9/4. Which actually, it's not bad. 2 1/4. Then we would have to. Nice. We have to scale it up. So if right now we have 1/7 of full productivity, we got to multiply by 7. What's 9 times 7?
84. 63.
63.
You
sound so sure, like 84.
And then Alex in his nice gentle way. 63.
Nice gentle little one.
It's not even like you're wrong, but we'll just throw the right one out there.
We weren't gonna try to like make it.
So yeah, that works. But we want an easier way.
It's like what we've been doing.
This is math. The rest of being lazy.
Do this algebraic.
Yay!
Do this algebraic.
Well, that's what we do. Actually.
What? So what's the unknown here? What? Okay, thanks. What does the unknown represent? Sorry, I'm teaching
amount
those.
of apartments.
No. That's, and the first time I worked through this, that's what I thought too.
Wait, what is it? What?
The amount of
apartments
apartments they can pay when they have all the students.
Yeah.
The amount that can be done,
Yeah.
right? They are 4/7. How many students we have doesn't matter at all.
I know, but
That
you
is
don't know.
not. That's fine that we don't know it. We don't need
Can I
to.
please have Rowan at the office? Rowan?
Essentially, this is like 4/7 of productivity, or 4/7 of our goal, right? 4/7 of the people. We assume everybody puts in the same amount of work, right? Truth be told, that wouldn't be how it works. But if 4/7 of your crew shows up, you'll get done 4/7 of what you anticipated to get done, probably. All of it?
I think I found the answer to how many apartments.
Okay, so hang on to it because we'll get there. But so we have 4/7 of the work that could be done, and what did they accomplish? 9. So what we have is 4/7 of what we shot for equaled 9. That's what 4/7 of our goal.
Is the amount of people?
No, that's how much of like the work we could have done.
Oh, so X is
Got
the amount of people and then.
No.
What?
This is why we're going to take a moment. X is really the number of apartments that the whole student group could paint. Because not everybody shows up.
Then what's a 4/7?
4/7 is how much of the group showed up. What portion. But that's not a number, right? That's not a number of students. That's a portion.
Okay.
You don't care how many students there are. That represents the chunk. It's the portion. Because we're trying to work with scale factors and portions. If you call it the number of students, that's okay, but it's not right. Okay? I'm just like number of students would be like 62 or something, right? Like we'd have a number of kids that showed up. That's the portion of the group. And also, it's the portion of the job we got done.
Awkward silence.
So I'm glad to be back with you guys. It's lame being homesick. So we got done a little over half of what we could, right? 4/7, a little over half. If we want to figure out what we could have gotten done, if everybody would have shown up, we solve this by multiplying by the
So the
reciprocal.
4/7 is the amount of people.
No! You can't have 4/7 of a person.
No, yes, you can.
4/7 of a
group of 7 people.
Okay, hang on.
There could be.
I was waiting for someone to propose this.
There could be 8
If-
and then.
If the group of kids that was supposed to show up was 7 people, then we could say 4 of our 7 people showed up. We accomplished 9 rooms, or 9 apartments.
Yeah.
But we don't know that there were. So sure, if that's what you want to think, that's okay. But we don't know and it doesn't matter. It's the portion. Portion. It doesn't have a label. It's representing a chunk, right? How much? It's really, we could percentage that if we wanted to. Then we multiply by the reciprocal. Oliver, you said you thought you had the answer. What do you think it is, sir?
So yeah, I took the answer for number 9.
Yeah.
Multiplied by 7 quarters, and I got 63/4.
Yeah, so what's that come out to be?
15.75 or 15.75. 15.75.
So that means if everybody showed up,
Did their
all 7 students, they could get done 15 3/4 apartments, right? That's what we were solving for.
job. Well, they could get done a little more than that. They could get done almost 60.
If they busted a move. If you gave them Red Bull, maybe they could do it.
If you
Don't
let them
drink
work
it.
a little bit harder.
Yeah, the commercial should say Red Bull gives you push. All right, so if now I wanted to save paper, and I don't think we have to hand this out, but I can, like, I have them if you want them. This is how we could have represented this situation. We could have said if we know that 4/7, these are the people that didn't show up, they overslept or something, got done 9, and we need to figure out, well, how many apartments would this chunk represent, and we try to, like, quantify it up. We could actually just, okay, if I double the amount over here, I double the amount over here. And if I keep doing that, I keep doing that. And we could get to a point where we have enough to quantify and make equal and then solve, and we still get the same answer. So I think we can probably skip past that. 2/3 x equals 8. What would we multiply by? 3 halves. Now hold on, think this through. I'm not even asking you to write anything out now. You can if you want. But if we're thinking about 8 times 3 halves, I want you guys to start to, like, cross-reduce pretty quickly. We're going to make this a fraction, which then means we can cross-reduce the 8, and that becomes 4. 12.
Wait.
Yes.
Can't you just take the 2/3 fraction and figure out how it can get to 8? What you can multiply 2 to get to 8, and then divide it? What? It's way more complex.
Sure, if you knew what value when doubled and divided by 3 equals 8, you could work it like that. But now, here's what you can't do. And I know I owe you guys some masteries, and you guys know I've been under the weather, so I'm going to get those back by Monday for sure. I was hoping by tomorrow. And I'm still hoping to get those back to you by tomorrow. You cannot use decimal representations in every situation. These sort of situations are where if we made this 0.66x equals 8, and you somebody do this for me with a calculator, if we did 8 divided by 0.66, what do you get?
And that's what you get. Calculator now.
Why do you have to have 1.1?
Because Ian needs to catch up.
12.121212. That's
Wait, you get it wrong.
zombie. That's not true. Hey, hold up. Come back here. Come back with me. That's not true because this statement is not true. It's close.
Oh yeah, we were talking about this last time, where you get closer and closer and more accurate.
So you put another 6 on here, your answer will be closer. You put another 6 on here, your answer will be closer. But we don't want to do that all day, so we don't. But you can't do that in the calculator. So you use,
You put in the fractions and then you take the decimal. You're like, die.
Alright, so
What? And you just like die.
You just put the fraction in there and it gives you decimal and then you just want to die.
No, it's like you're just like die. Mr. Hudson is full of die. He's just like, you know what, whatever, I give up with this class. He's done with it. Next class. Blue hand here.
Hello.
He's waiting for us.
Show your teeth. That's the way to put it well, but
No words. Heart over home. Yeah, that's a fraction. Yeah, I know. There's a percentage you put over home.
what's, because you guys were doing plenty of it. What's the easy?
Good morning. Kylie Cannon, head to the office.
Okay, guys, start talking.
What's the fastest way and easiest? Right? I'm trying to make your life easy. What's the fastest and easiest way to turn 8,500s into a whole number?
Add 5.15.
Multiply by 100.
Say it louder.
Multiply by 100.
It is currently 8,500. Right? No, hang on. Stay with me. Write this down. Right, 0.85x equals 36.21. If we multiply by 100, we got to do it over on the other side, right? So we do it over on the other side. Now, that's really, really good for us, actually.
because it's 3,621.
Then
Just divide both of them by 85.
we can just divide by 85 because we actually have 85 times the quantity that we're looking for.
Wow.
So now on both sides, well, that I just put the bar, but now we're going to make it a fraction. To get rid of the 85, we divide by 85.
So X.
What is it?
42.6. No.
I like fractions more.
Lana.
So, in the very beginning, I just got the 36.21 divided by 0.85 and I got 40.
You're like a lesson. Yeah, you're exactly right. So, what Alana figured out was what we're leading you to, ever so gently. Well, actually, we're kind of going sort of quickly. That what we could have done, instead of multiplying by the reciprocal, which is essentially what we just did, we multiplied by 100, then we divided by 85, you could actually just use inverse operations, and from the gate, like from the start, we just say, well, what we really want to do is turn that into 1. A number divided by itself becomes 1. If we divide by 0.85 here, which a lot of us probably could get to at this point because we've done enough practice, that also will get us to 42.6. Questions? And your calculator gives you a decimal. And so, here's the question. Could we solve these? Take 5 minutes to work on your homework. That or, hey, hold up. Or, alternatively, do we spend 5 minutes on the next lesson and just put homework time in tomorrow? So, I will be the guiding voice of an adult in the room and say it's better to just use this time right now and spend a larger chunk on homework tomorrow. So, if we looked at, and this, I gave you guys a couple of these problems on the Chapter 5 Mastery to see where we were at and how you guys were doing them and why you skipped it. Calm it down, Attitudey.
You was almost crying on the box.
No, it was not. That's not true. She's lying.
Sorry,
His eyes were so
real men cry, Blah.
What was
Okay.
his eyes were puffy red?
Annie.
What were you all mad about?
No, finishing your test. I was not. I promise. I swear.
Yes, you probably.
I was
Seems a
angry.
lot that since you're swearing and promising that you did. I believe.
Or he's joking. He wouldn't name their test.
Oh my gosh. It seems a lot like.
Guys, can you please be quiet?
No.
There are like 3 or 4 people in this room that have some of the largest amount of passion for learning and discovering and actually like making progress with their brain. And Blah's one of them. So for as much as you guys want it in your middle school way, be like, did you actually care about a test that much? Like, one of the reasons that I keep teaching, because there's a lot of other jobs that could pay me a lot more money, is people like Blah, or Annie, or Rachel, or Nina. Or, I mean, you guys have amazing people in your class. Don't pick them. Pull from their energy. They care more than you do. Maybe you don't care enough. So, if we had an equation like this gets a lot more messy. Think about this for a minute. Actually, for the next 2 minutes, the last 2 minutes of class, I challenge you now. Again, there's like a million ways to get to Florida. I challenge you to figure out the best, easiest way to get X isolated, to solve for X. That's not going to help you. Trust me, we're dividing by 3 calculators, your biggest enemy here. Now, Sherry has an idea, and she draws this model. I argue that that's not that awesome. I mean, unless she knows what she's going to do. Because we want to use integers. We want to use entire numbers. You still got a minute if you want to fight with this a little bit. Sherry.
You said everything but the one. You said try.
Or it could be short for Charizard.
I said Sherry first, and then I
Wait,
made
guys. Did you play Pokemon Blue?
No, but I know of it. I played. I never got into Pokemon.
Yes.
Alright, so we're going to pick up tomorrow. Obviously, weird schedule, Friday schedule. We're going to pick up tomorrow with this question. I'll be curious, if you think you know the best way to do this, come see me. Today or early tomorrow, if you think you've got the best solution, come see me. Have a wonderful day, guys. Yeah, well, I mean, here,